Hello, welcome back to Chapter 8, Section 3, Adding, Subtracting Rational Expressions. And in this video, we're going to do some practice problems, page 588, problem 7, 8, and 9, where we're going to add rational expressions. So here's the steps. We have to factor the denominators. Don't have to worry about the numerators, but we have to factor the denominators. We have to find the least common multiple, which since we're talking about fractions means least common denominator, by including whatever factors are missing. So if they share something, we leave that alone. But if one of the denominators has a factor that the other one doesn't, then we need to make sure we include that. And we include it by multiplying by the number 1. So this problem looks kind of simple, but actually if you look at the next two, which I'll show you in a second, this one's actually a little bit more than the other ones. So it's a little deceitful, I suppose. Notice that the x plus 6 and the 2x minus 1, I don't need to factor those. So watch what happens. I like to write things vertically, so I'm going to write 3x subtract 2 over x plus 6. I'm going to put parentheses around everything, because I'm going to be multiplying, so I'm going to need to group that. And then I've got 2x subtract 3 divided by 2x subtract 1. Again, I'm going to group those, put plus sign right there. So factor x plus 6. That's it. It doesn't factor any further than that. Factor 2x minus 1, same thing. So I have two denominators that do not have any common factors. So what that means is I have to multiply this x plus 6 times the 2x minus 1. Now I can't just do that. I have to actually multiply by the number 1. And what makes the number 1 when I have something divided by itself? So again, this is just the number 1. Now I'm going to come back and work that out in a moment. I've got lots of multiplying to do here. But in the other fraction, it has a 2x minus 1. It needs the x plus 6. And again, I'm multiplying by the number 1. So that has to be something divided by itself. Okay, now pause the video if you need to and look at what I just did. Now the denominator for both of them is whatever x plus 6 times 2x minus 1 is. This is the same, it's just not in the same order. The commutative property tells me I'm going to get the same thing. So what do I got to do now? Let's multiply the denominators, and that will be the same for both of them. And again, you can use a multiplication chart, or you can use FOIL if you want. Your pre-calc teachers kind of want you to use FOIL so you can do it in your head. It's okay. 2x squared, 12x subtract 1x is 11x, and 6 times negative 1 is negative 6. And the cool part is that's going to be the same as this one. You don't have to remultiply it, because that's the whole point, to have a common denominator. Now let's multiply the numerator here. 3x times 2x is 6x squared. Negative 3x plus negative 4x is negative 7x. And again, pause it, make a multiplication chart if you need to see it. I'm doing this stuff in my head. Negative 2 times negative 1 is positive 1. In this numerator, I get 2x times x is 2x squared. I get 12x subtract 3x, which is 9x. And negative 3 times positive 6 is negative 18. Now, I hesitate to say this, but invariably somebody always asks, shouldn't I reduce these? Well, if you reduce them, you're going to get back to where you were. That's not what I want. So what I'm doing is I'm kind of, and this is a word I'm making up, I'm unreducing them. So I'm going the direction away from reducing, so that I can have a common denominator. That's what it is. Once I add these two, because they're being added, once I add these two, then if I need to simplify it further, I can. But this unreducing allows me to have a common denominator. So now I'm going to keep moving. I'm going to add, and I've got 2x squared plus 11x, subtract 6. And now let's add the numerators. 6x squared plus 2x squared is 8x squared. Negative 7x plus 9x is 2x. And 1 plus negative 18 is going to be negative 17. Okay. Now I need to check one more thing. And this is going to get a little complicated. If I can factor 8x squared plus 2x subtract 17, if I can factor that, and one of the factors is here, then I know I can reduce. There's two ways you can do it. You can straight up factor this, if you can. Or you can see if you can divide this by x plus 6 or 2x subtract 1. We learned about dividing, because dividing is kind of like factoring, except you already know what one of the factors are. If this reduces, then one of the factors has to either be x plus 6 or 2x minus 1. Okay, so here's what I can do. And I told you this is the hardest problem that we're going to be doing here. Here's what I can do. I know that x plus 6 cannot be a factor. Why? Because 6 is not a factor of negative 17. Negative 17 is, well, 17 is prime. So negative 17 is only going to be negative 1 times 17 or positive 1 times negative 17. Now the thing is that it might be 2x subtract 1. So I can try to see if I can divide this by 2x subtract 1. And I'm going to do it using the area model, which is basically the multiplication chart. So maybe 2x subtract 1 works. And I'm going to put a question mark because I don't know if this is going to work. So this would be 8x squared, and this would be negative 17. These two are going to add up to 2x. Let's see if this works out. What do I multiply 2x by that equals 8x squared? That's 4x. 4x times negative 1 is negative 4x. Now, what do I multiply negative 1 by that equals negative 17? That's positive 17. 2x times 17 is 34x. And 34 plus plus negative 4x just gives 30x. So no. This is not, if 2x minus 1 was a factor, these two would have added up to 2x. So they didn't. This is not 2x. So x plus 6 is not a factor, 2x minus 1 is not a factor. That's it, I can stop. Except I got one more thing. Which x values make the expression undefined? Right here, look at my factors. So x cannot equal negative 6. If it does, I get negative 6. Actually, I pointed here, but I should have pointed here. And x cannot equal positive 1/2, because 2 times a half is 1, 1 minus 1 is going to be 0. Okay, again, that one was really complicated because they did not have a common factor, and I had to check this at the end to see it wasn't obvious if I could have reduced it. Maybe the next one might take it easy on us a little bit. No promises though, okay? All right, so I got 4x subtract 5. And I'm going to go ahead and factor this. It has a common factor of 4. This is 4 times 3x plus 1, which is nice because that's what that is. So my other fraction is 3x subtract 1 over 3x plus 1. Believe it or not, this one's actually a little bit easier because they both share a common factor in the denominator of 3x plus 1. But this one has a 4. So all I need to do is multiply this by 4 over 4. And again, that's just the number 1. Excuse me. So I didn't do anything with this. This is 4x subtract 5 over 12x plus 4. I remultiplied it, but I already knew what it was. 4 times 3x is 12x, and 4 times negative 1 is negative 4. And don't do anything with this yet until I add. 4 times 3x plus 4 times 1 is going to be my 12x plus 4. Now I have a common denominator. I'm going to add these two together. My denominator is 12x plus 4. And my numerator is going to be 4x plus 12x, which is 16x. Negative 5 plus negative 4, which is negative 9. Now it looks like right here 3x plus 1, it looks like x cannot equal negative 1/3. I'll let you do 3x plus 1 equals 0 and solve. That's Algebra 1 stuff. Can I reduce this? Well, it looks like I've got 4 times 16, 4 times 3, and 4 times 1 here, but I don't have 4 as a factor of the 19. Oh, excuse me, the 9. I didn't mean to say 19. So I'd have to, if this was like an 8, yeah, I could probably factor out a 4 from the top and the bottom and then cancel that. Don't say cancel, I gotta stop that. I could reduce it, but at this point, there's no common factor between 16x squared and 9. So that one's going to be finished. Problem number 9, 3x subtract 4 in the numerator. In the denominator, I got x squared subtract 9. That's a difference of 2 squares, so I do x plus 3 times x minus 3. For the other fraction, I've got 2x subtract 1 over x plus 3. I don't know why I wrote it a little bit to the left. Oops. Now they both share a common factor. The numerators, I'm sorry, let me move that up. They both share a common x plus 3, but this one has the x minus 3, so I need to include that here by multiplying by 1. Again. So my first fraction didn't change. That stayed the same. My second fraction, my denominator should be x squared minus 9. That's what I want. I want the same denominator. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Minus 1 more x is negative 7x. And negative 1 times negative 3 is plus 3. Extend that out a little bit. Now I'm going to add these two together. My denominator is the same, so I can take care of that right away. 2x squared, nothing else up here, 2x squared. Negative 7x plus 3x is negative 4x. And negative 4 plus 3 is negative 1. I have to check to see if it can be reduced. I know that the only way it's going to reduce is if x plus 3 or x minus 3 is going to be a factor. And neither of those are going to be a factor because of the 1. 3 is not a factor of 1. So that one's good. I can stop. I also need to identify that x cannot equal 3 and x cannot equal negative 3 because both of these are going to make this, negative 3 and positive 3 are going to make both of these divide by 0. Okay, in the next video we'll do the exact same thing except with the additional step of subtraction means adding the opposite.